section, we're going to start talking about how we can find x-intercepts for some quadratic expressions when the leading coefficient is not equal to 1. And to get us started, we're going to go through this example in the explanation first by going through this process of finding the x-intercepts with the original function in factored form, and then we're going to practice with this process of factoring a trinomial when things are FOILed out, in order to go through the process of practicing with the factoring process when the leading coefficient is not equal to 1. So for this function f of x, the first thing we want to do is to determine the x-intercept. And to find the x-intercept, we're doing the same thing as what we did before, that if we want to have that, we want to get the function equal to 0, because x-intercepts has a y value equal to 0. So really the first thing we want in order to find the x-intercept is to let this whole function equal to 0, meaning that 3x plus 2 times x plus 4 is equal to 0. And to go from here, we're again going to use a zero product principle, telling us that if we have a product of two expressions equal to 0, that tells us either factor can be equal to 0. In other words, in this case, we have 3x plus 2 can be equal to 0, or we can have x plus 4 equal to 0. And this becomes two linear equations for us to solve. For the first one, to get x by itself, we can subtract 2 first on both sides and get 3x equals negative 2. Then divide 3 on both sides, gives us x equals negative 2/3. Alternatively, if we had x plus 4 equals 0, that tells us x can be equal to negative 4. And now if we know these are the solutions for x, we can state that the x-intercepts are going to be negative 2/3 comma 0 and negative 4 comma 0, because these are the two x values that would make the function equal to 0. And this is a part where utilizing zero product principle again. But now what we want to bring into this content is think about what if we don't have a factored form of a function to start with. And to get that sense of the factoring process, what we're going to do is to FOIL out this given function. And in order to do this, we're going through some algebra first. Really quick, if we have f of x equal to this, going through the FOIL process, we would have 3x times x first, which would be 3x squared. These are the first terms. Outside will be 3x times 4, so we have 3x times 4 in this case, or if you see it, it's exactly 12x. And I'm going to just write out as a reminder what FOIL stands for. So f is first, O is outside, meaning the two terms outside on the outside of the expression. I will be the inside, and lastly L will be the last terms in each parentheses. So we've done the first 3x times x, and then we've done the outside 3x times 4. Then the inside we have 2 times x, and last we have 2 times 4, which would be 8. And altogether, if we simplify things a little bit, we would get 3x squared plus 12x plus 2x plus 8. And we want to combine any like terms we have, and we should expect to get a trinomial overall, meaning a polynomial or a quadratic expression in this case with 3 terms. And once we have this form, we're done with a FOILing process. Then we want to think about how we can factor this back. Imagine if your original question was telling you that f of x is equal to 3x squared plus 14x plus 8. We want to think about how would we go ahead and factor by hand and find out what the x-intercepts are going to be. And in order to do this, we want to first notice a few things. The leading coefficient in this case again is not equal to 1, as we said at the beginning of this section. The leading coefficient here is 3, that's a equals 3, and we have the value b equals 14 and the value of c equals 8 over here. And with this information, in order to do the factoring process, we have this method that sometimes may be called the AC method. and it's called the AC method because we want to incorporate the value of a and c to start with. And in order to find a and c, we already did that, and we want to find the product of a and c first. So we want to do a times c, which would be 3 times 8, equal to 24 first. And now, slightly different from what we did was the case when leading coefficient is equal to 1. Our goal now is to find two numbers that would multiply out to be the product of a times c and add up to be b over here. So here we want two numbers that would sum up to be still b, which is similar to what we did when leading coefficient was equal to 1. And now we also want the product to be equal to the product of a times c, which is 24. And to find these two numbers, again, it'll be similar to start with the product being 24 and think about all the factor pairs we can possibly have. Because the product is a positive number, that means our two numbers should have the same sign, whether they're both positive or both negative. And now with the sum being positive, that tells me these two numbers must both be positive. Imagine if you had two negative numbers added together, you wouldn't have a positive sum. Therefore, I know I'm looking for two positive numbers that are factor pairs of 24. And at the very beginning of your factoring process, it'll take you a little bit longer to find out the correct numbers, and there's absolutely nothing wrong with that. We can just go ahead and list out all the factor pairs of 24. So for example, I know 1 times 24 is 24, and then we can have 2 times 12 equals 24. And if you're familiar with it, you'll notice that 2 plus 12 will give you 14. But let's say if you didn't go to this pair first, you can get 3 times 8, 4 times 6, etc. And once you have all the factor pairs out, as we stated before, because the product and sum are both positive, we don't need to worry about changing the signs in front of our factor pairs at all. These are all going to be positive. And now with this, we can try to go ahead and add all the numbers together. 1 plus 24 will be 25, etc. And we said a bit earlier, if we have 2 and 12, we can have 2 plus 12 is going to be the sum of 14 with a product of 24. Now that tells me we found the correct numbers that we want to work with. Once we find this number, we're going to go back to the original FOILed expression. And f of x is equal to 3x squared plus 14x plus 8. So what we're going to do with these two numbers is we're not going to write things out directly in factored form like we did with leading coefficient equal to 1. Instead, we're going to rewrite the original function. The original function has 3 terms, and what we're going to do is to create 4 terms, so we can do factor by grouping. And to do this, we can leave 3x squared as is, and we can leave the constant term as is. So the only thing we're changing is the middle term, the linear term. And the reason we can do this is I know what two numbers would add up to 14 now, based on our process of finding the factor pair that would work. So now instead of writing 14x, I can write it as positive 2x and positive 12x over here. So once we have this form, we have 4 terms, and the goal is for us to factor by grouping, so I'm going to go ahead and group them together. And the first 2 terms will go together, the last 2 terms will go together. And just to not having to worry about the sign changing at all, here I have a plus or positive 12x, so I'm just going to put this all together in the second group. But remember, these terms are connected by addition, so I'm going to put a plus sign in the middle. So with this, I don't have to worry about it if I had a negative coefficient in the beginning of the second parentheses at all. I can still carry on with the business with a plus sign in connecting the 2 groups. And now going back to factor by grouping. For the first group, we want to think about what's there in common as a factor. The first group, we should have the variable x in common, so I'm going to go ahead and factor that out. That gives me 3x plus 2 that's left. and still connected by the plus sign that we use to connecting the two groups. And now from the second group, we have a positive 12x and a positive 8. Again, we want to think about what's a common factor. Here, the greatest common factor is going to be 4. So I'm going to go ahead and take out the 4. And that leaves me with 3x plus 2 over here. And with this, hopefully this looks familiar with the factor by grouping that you may have practiced with a little bit more. And notice that we get 3x plus 2 from both groups. And from here, we're going to take that out all together as a group. We have the 3x plus 2. So once I factor out 3x plus 2 from the first group, I'm left with x. And once I factor it out from the second group, I'm left with 4. So I would end up having 3x plus 2 times x plus 4, which is exactly what we had in the original question. And this is the AC method for factoring, and that's particularly helpful when we have a trinomial when the leading coefficient is not 1.